a co-founder of Anabranch Solutions, which is a company that has over a decade of practice designing, implementing, and monitoring low-tech process-based restoration projects in the US. Stephen, thank you so much for joining us. We are really excited to learn from your extensive experience implementing this type of restoration. As everyone in this call is likely aware, low-tech process-based restoration is a pretty new practice in BC, but it can serve as a critical piece to watershed scale restoration and climate change adaptation and mitigation. So I'll pass it over to Stephen to learn more about understanding potential risks, uncertainties, and benefits of low-tech process-based restoration.
All right, thanks very much, Jennifer. Can you hear me? I guess is my first question. Great. Yeah, just let me know if for whatever reason that changes. So yeah, I think my goal today is to maintain the excitement that Jennifer just talked about. Also clear up some confusion because like any new thing, people misinterpret or don't understand some of the key components. And then I think there's also a fair amount of fear out there because it is growing so quickly that maybe we're going to commit some of the mistakes we made in the past of when we were trying to do restoration. So that's my main goal. All right. So just thanks for that introduction, Jennifer. I do wear these two hats. I'm an adjunct at Utah State University, and I'd run a company with Dr. Joe Wheaton and Nick Bowis. And we've been studying this really since 2005, so we're coming on 20 years now. We're also lucky because monitoring is expensive and difficult, especially when you start trying to detect changes in a statistical manner. And about 20 years ago, people in the west side of Washington and Oregon, where hundreds of millions of dollars are being spent on salmon and steelhead recovery, they realized that small kind of monitoring projects with limited funding just weren't answering the basic question of, is restoration working? And so they used some of the ecosystem experiment literature that had happened in other places to develop what they call intensively monitored watersheds. And basically the role of these watersheds was to conduct experiments to test the most common types of restoration, things like barrier removal, a large wood enhancement. And we were lucky enough, our group, to be able to run two of these experiments, one in Bridge Creek, Oregon, which is in the John Day watershed, and one in Asotin, Washington, which flows into the directly into the Snake River. And those are both low-tech projects. Bridge was a BDA project, and Asotin is a post-assisted log structure project. And so those have been running for almost 20 years now, and that has given us a lot of insight into these methods. And just to sort of beat a dead horse, that one of the reasons I'm here talking to you is like I talk to lots and lots of other people, and we've put on workshops all over the place. There has been this explosion in interest and research on beaver in particular, and this is a graph just showing me doing a citation summary over years with the words beaver and either restoration or ecosystem. And so you can see a lot of publications have really started to come out right around the time we started these intensively monitored watersheds. Our group helps to organize this website. It's called the Low Tech Process Based Restoration Explorer. You type that in, it's easy to find. Anybody can register. And we're just trying to track projects. This is by no means all the projects, but it does give you a sense that, you know, a lot of stuff's happening. 230 projects, 90 organizations, you know, almost 300 miles, and we're coming up on 20,000 structures. And this is absolutely an underestimate of what's going on because it's just voluntary. Even our own company has trouble just keeping up and adding all our projects to this. So I wouldn't doubt if it's, you know, close to double this already. But obviously, it is growing. So lots of people are doing this. You might say, yeah, but those people, you know, are maybe small organizations that they're not big players, or, you know, we can't really trust that they've looked at this carefully. Well, many of the workshops that we put on and the manual that we wrote, which I think Jennifer can make available to people, it's free online. It was partly funded by the NRCS, the Natural Resource Conservation Service, which is one of the largest federal agencies under the USDA that hands out over $2 billion to private landowners to do conservation on their land. And so we've probably given almost 20 workshops to their staff all over, and they've been big adopters of this now. And the guy in the middle of that photo is actually one of the main biologists that managed to get this particular type of restoration added to what they call the conservation practices for the NRCS. And they're very rigid and very rule following in that organization. And landowners can apply to get money up to 90% funding for a project. And now they can build BDAs on their property or PALs through this program. Also, the largest landowner in the United States, the Bureau of Land Management, has sort of doubled down on this low-tech approach as well. And there's a large initiative now where they're highlighting target landscapes and riverscapes and watersheds. And one of the focuses is on restoring the health of the aquatic ecosystems on those lands. And although there's a lot of private land down here in the West, it skews heavily towards federally owned land. And in Nevada and Utah, it's almost 70% or more federal land. So there's a lot of federal land that this kind of stuff can be applied to. So that's just my little stump speech about, you know, what's kind of going on, and yeah, it certainly is a growing thing. So the message that I kind of want to deliver is two-part. One is that it's not that complicated. If you take a degraded riverscape and you connect it to its floodplain, and you allow some of the natural processes to take place, and the extent of the riparian increases, water retention on the land increases, it's going to increase the productivity of that area. And that's more than likely going to improve fish habitat and productivity, which, for a lot of the things we do down here, that's the main driver. This also applies, though, to sage grouse, where here we have the Endangered Species Act, which is pretty powerful. And they're actually working hard to not list the sage grouse, which covers 11 different Western states. And one of their tools for trying to keep them off the endangered species list is to do riparian restoration because it's a critical time for the chicks to grow quickly. That even though they live out in the sagebrush, they congregate around riparian areas when they're young, and then they can grow quickly and have higher survival. So that's the obvious message. The much more complicated one is that once you start to try to fix these places, you should understand something about the context. And I don't want to get in the weeds on this stuff, but I'm lucky enough to work with fluvial geomorphologists, people who study rivers and the form and function of rivers. And you don't have to be an expert in that, but you have to know when you don't know enough to ask somebody for help. And there's certainly places where this kind of work won't work or will take a very, very long time. And so this really helps set expectations. And then you have to scale the restoration to the scope of the problem. This will be a theme that comes up over again. And it's good to start with small projects that you can get your feet wet. You can figure out some of the uncertainties in the stream you're working in. But if you want to detect, large increases in whatever you're interested in, you have to scale that up. Nothing works at really small scales. And then what we've learned is that this isn't a one and done. Really, no restoration was ever a one and done, but it was maybe never said. We're not afraid to say it. It's going to take time to fix these landscapes. They took decades or centuries to degrade. They're going to take time to fix. So maybe you have to go back and do more than one treatment or do maintenance. You may even have to do adjustments, realizing as you this is the kind of thing you can implement and learn as you go. Maybe you adjust some of the things you're actually doing. And I said time. There's uncertainty in a lot of this stuff, but we're comfortable with uncertainty, and we're only comfortable with it because we take an adaptive management approach to implementing this stuff. So there's the simple adaptive management wheel. You plan, so you try to figure out what's broken. You try to come up with some hypothesis. You do something. You then evaluate that, and you either adjust or you learn, and you just keep going around. And this can be very complicated, but we did write a paper on how to do this in the simplest way that you can kind of get away with. Right, so just a quick outline, just give a little background. It sounds like we've got a fairly diverse group, so make sure that we're all speaking the same language. And then I'll cruise through planning a little bit and design, because that sort of is the precursor to getting a permit. We'll talk a little bit about permits. I'm by no means an expert. I find permitting a little frustrating, but it's extremely important. And the good news is that we get most, if not all, of our projects permitted, so it is possible. And then we'll just go through some lessons we've learned on a bunch of case studies, and we'll wrap it up. What I'd like to do now is do a poll and get to know the people on the line a little bit. So if you could go to this website, menti.com, and enter that code, you should be able to start getting some questions and see things on your phone that I can, hopefully you can see now. So you should see this screen, an introduction. I see a lot of fingers pop or thumbs up, so I'm assuming that means people are on there. Let's see. Okay. I can see people signing in, so I'm just going to wait a little bit till we get the majority of people signed up. And the code and the website is on top of the screen here as well, if you didn't get a chance to get it when I switched screens. So it's just menti.com, 25.99, 97.42. I only see about 30 people on there. Slowly catching up. I probably caught everybody off guard. All right, we're getting close to half. So here's the first question. If you've got your phone, yeah, you should just be able to start saying what it is that you mostly do. We've got a problem here if there's no funders. All right, a lot of planners. It's good. Could people that say other enter in the chat what it is that other is to them? So I'm curious to see what I'm missing. And Jennifer, if you wouldn't mind reading some of those out to me, it's just a little harder for me to pop back and forth. Maybe I can do it here. Let's see.
Most people are saying other includes all of the above or a regulatory perspective.
Right. I see that I screwed up and I didn't put regulatory on here. So that was my bad. Good. Okay. Well, that's a pretty good spread of people there. We'll go on to the next question. Thank you for that. I think I know the answer to this question, but I've been away from British Columbia for 20 years, so maybe things have changed a little bit, but I believe you have to enter. Yeah. If anybody's confused what easement is, I think of things like Trout Unlimited or the Nature Conservancy that own land. I didn't know whether to call that public or private. So, but down here, they do quite a bit of low tech. All right, well, let's see, that fits my assumptions. Things, oh, look at that. There's quite a bit of conservation land or whatever we want to call it. But not maybe totally surprising that public land is leading the way in British Columbia. All right. I tend to get sidetracked, so I'm going to keep moving on here. And this is mostly for my benefit, but I appreciate. So basically asking here, if there was one thing that you wanted me to talk about, what would it be? What's other than all of the above, but you can pick that if you want to, that's okay. Everything, I guess, is what we're getting here. With permitting being my weak link, you're going to be a little bit out of luck there, but I'll do the best I can. All right, a broad group of people with a broad group of interests and things they want to know about. And this app that I'm using, the first time I saw word clouds, I was like, okay, that's cool. I have to try to do those occasionally. So this is, yeah, what's the first word that comes to your mind when you think of low tech? Okay, I don't think I've ever seen frog before. That's good. Cost effective is an easy one. Ask me about, I don't really have cost anywhere in the talk specifically, but that's something we should come back to. All right, well, I should have taken a picture. I just gave a talk to all the conservation districts in Washington a couple of weeks ago, and beaver was right in the middle of the word cloud for those guys too. So, and natural wetland resilience, those all look like, and floodplain and wood. And oops. All right. Yeah, that is also a theme, is that beaver really dominate a lot of what we talk about. All right. I'm going to pause. We'll go back to the presentation, but maybe before I go on, is there any questions just related to this introduction? Well, there's lots of time for all the details, but
there's no questions in the Q&A tab yet. We did have one question in the chat, which I think you're going to touch on in your presentation. Andrew from the province was asking about examples of when this type of work wouldn't work, or pointing out red flags.
Yeah.
Okay.
Yeah, I have a section on that. And so we'll talk about that quite soon. Okay, so
people have questions throughout the presentation, feel free to use that Q&A function. It's a tab that's right beside the chat tab on the top of your screen.
Yeah, we will stop every 10-15 minutes and then have questions. We'll jump back to Menti a few times. I do want to hear as many questions as we can get to. Okay, so we'll just go over a quick background, scope of the problem, and just what is this approach that we're talking about. This is my very simple graph of what happened in the last couple hundred years. This is obviously a little bit skewed, maybe minorly skewed towards the Western US. I don't have as good a sense of the beaver trapping in British Columbia, but my next slide kind of addresses that. The point of this slide is that we trapped out beaver pretty quickly. It didn't take a long time to reduce the population, and then they've been recovering ever since. And then, of course, we just had all the development that happened after that somewhat suppressed the beaver, but also increased the stream degradation. I wouldn't mind a poll of who's read or heard of this book, but I live in a small dairy farm community in northern Utah, and I hadn't heard of this book, but one of my neighbors, who's 20 years older than me, and I'm an old guy, said that he read this in middle school. It was required reading. And this is a story about an English gentleman who moved to Canada, moved to the Chilcotin, married a native woman, and lived 50 miles out in the woods. And this couple realized that the beaver had been trapped out of the valley, and everything, all the wildlife had left, and all the riverscapes had degraded. And so they actually, in the 1940s or 50s, got beaver relocated back to their property. And this is just a story that documents that. So it tells me that similar things happen in British Columbia, just this one anecdotal story. Why do we care? Well, the way we teach this stuff really is we think of structure, beaver dams and wood and vegetation. They're the structure in the floodplain, and that structure affects flow. And when you affect flow, you change the velocity and the movement of water, and that increases the geomorphic complexity. You're creating fast water places where you scour. You're having depositional areas where you're building bars, and all of that together just creates this complex connected riverscape. And many people have now commented on what we've lost, right? This is a picture of what we've lost. There's still obviously examples of it out there. We have some great examples not far from where I live. We have amazing beaver colonies that are producing this kind of a landscape, but we've probably lost 50% of it or something like that. It's a large amount of this kind of habitat that we've lost. And with that, we've lost this influx of wood and this storing of water and just all the productivity that goes along with that and all the other ecosystem benefits. And I travel around a lot in the West. It's a pretty arid place. And this is what I see a lot of. This is certainly one of the worst examples, but this is a sad little stream that is incised and not looking very happy. I don't know what it looked like 200 years ago, but if you take a step back, so the photo is where that red arrow is pointing on the previous slide. And what we've seen in many places is that when that incision happens, the stream cuts down. That happened relatively quickly, and it was because of the loss of beaver and or wood and or straightening of the stream that increased stream power. And basically then you have more erosion happening than deposition, and the stream cuts down. And when it goes down, the groundwater goes down with it, and you've now disconnected the stream channel from the floodplain. The yellow bars there, or dots, are the floodplain. And that just reduces the ability of this landscape to support riparian vegetation, and so you get encroachment of upland, and you've lost productivity. And this is just what it looks like in a cartoon form. And incision is a natural process, but there's ample evidence that we have increased the amount of incision out there. And it does recover by itself, but it takes a long time. It happens relatively quickly, but it takes a long time for it to get back to a more connected state. We also have a lot of streams that look like this, which if you asked most of the public, they would probably say, oh, it's a beautiful little stream. And it is a beautiful little stream, and it actually has steelhead going up it every year. This is in Southeast Washington. But it's lacking structure. The beaver are gone. There's photos of beaver dams and beaver being here in the 70s and the 60s, but they've all been eradicated. And there's just a lot less large woody debris than there used to be. And it's been straightened. This is a picture that Jennifer sent me from some of the proposed works that she's doing. And the only reason I'm putting this here is just to say, the stuff I see down here looks just like the stuff that the BC Wildlife Federation are proposing to work on with their partners. So this is, again, I'm pretty sure that this is a common thing up in BC too. All right, so we'll hop back in here real quick. Everybody's got it all figured out now. Like I mentioned, I've been away from British Columbia. I grew up in Prince George, went to school in Vancouver, but I've been away for 20 years. I don't really know what the number one pressure is. Down here in a lot of the arid West, it's ranching, but it's really site specific. Oops, a daisy. All right. I think if we did this down here, dams and reservoirs would pop up a lot more because in Utah, for example, I don't know that there's a river that doesn't have a dam on it. Because they're so water limited, there's reservoirs on practically everything. And then for those that don't know, the Columbia River and the Snake River have a plethora of gigantic dams that are part of the reason, or most of the reason, that the salmon and steelhead are endangered down here. All right, forest. I'm going to guess that forestry is maybe leading the way. I lumped it in with ag and ranching just so I could add climate change, and somebody could tell me that I didn't include climate change, so I threw it in there too, which I think Jennifer alluded to, with the potential to mitigate climate change impacts. All right. So this is just a loaded question. Since it's anonymous, I'm hoping people will be honest. All right. That's a good vote for Beaver. All right, I keep hitting the wrong button. Okay, I'll move on to the next one. I don't know if this needs a little bit more description, but is there one group that is more pro beaver than another, I guess is what I'm asking. All right. Well, that's interesting. Really happy to see First Nations. I have a friend who works in Prince George. I won't call out, but they mentioned earlier, like 10 years ago when this was still taking off, that the First Nations were concerned about beaver dams. So I'm hoping that's gone away now. But and I will talk a little bit more about the limited support. That's something that I want to touch on. Okay. Just checking the time here. So that's 40 minutes in. Yeah, maybe we'll finish up a little bit about the approach and then see if we want to take some questions. So here we have a picture of downtown Reno and a large restoration project. This is the Truckee River. I think this is a good example of, a compromise between getting the water through a city and giving it some level of diversity. A lot of restoration in the past had sort of what they call form-based, so you're trying to build a river the way you want it. There was a high degree of precision that you wanted, how high the water would go in a 100-year flood. You wanted it to be stable and predictable, and that makes 100% sense in places like this. And then along came process-based restoration. Before there was low tech being written about, there was just process-based, which is essentially a bunch of smart scientists in NOAA fisheries on the West Coast, again, seeing hundreds of millions of dollars spent on salmon and steelhead recovery and a lot of it was looking like it wasn't effective, or you couldn't demonstrate it was effective. And it may have been for the simple reason that they weren't addressing the root cause. They weren't tailoring the restoration to the local setting, or this restoration wasn't scaled up enough. And just as importantly, people didn't have explicit outcomes that they were trying to necessarily attain, and they weren't articulating those well. And so process-based restoration really took off in the mid-90s, where people recognized that we had to move away from form-based where we could, and just try to restore the natural rates and magnitudes of natural processes, like physical and biological processes that sustain rivers. And all we did was really add the low tech to the process based, and said, okay, well, there's a need for restoration that isn't always done with an excavator and engineers. We've got all these small streams which make up the majority of a watershed that often they're getting ignored. So we're focusing on letting the system, which is the water and beavers, do the work, as much work as possible for us. And we're trying to do as much of it by hand when necessary to avoid, degrading things further. Now, it just so happens that this isn't new. People have really been trying to relocate beaver ever since we trapped them out. And that picture on the left is that famous beaver who had a name, Geronimo, and after the Second World War, they had an excess of pilots and parachutes, and so they tried to figure out how to throw a beaver out of a plane in a box that would open and let the beaver go, so they didn't have to drive out and release beaver. They could just throw them out the plane. And Geronimo, I think, did 11 test jumps before they got the box figured out right. And then on the bottom right, that's a picture that looks an awful lot like a schematic for a BDA that was in a 1934 Forest Service stream restoration manual. So really, we've just rediscovered things that people used to do, and then we kind of got infatuated with the big machinery and forgot about this stuff. So we don't have a lot of tools in the toolbox, but Beaver Dam Analog is one of the main ones. Here's just some schematics. We're driving posts, weaving material, or maybe doing it in some other ways, adding some sediment and trying to mimic a beaver dam. Here's a picture of some of the early beaver dams we used to build. And then we make log jams, and we just take smaller logs that we can move with two to four people, and then post them in using the same post technique that we developed for the BDAs. Just forgot to mention, the BDAs are for ponding and grading the channel mostly. The PALs, or post-assisted log structures, can scour, they can widen, they can split flow, they can also pond and grade. And here's some of the early structures we built. Very simple, nothing fancy. And finally, we developed some principles to sort of help us figure out, well, what is a healthy riverscape supposed to be? And one of the main ones is that it needs space. We encroach on the floodplain or the valley bottom a lot. That makes it very difficult to use process-based restoration if you're taking away part of the natural valley where the contemporary flow regime would be operating in. So, you should be trying to do these in places where you have the space. We talked about structure forces complexity, but there's lots of places where structure, either log jams or beaver, are not a driving factor in the river style, and so you shouldn't be trying to work in those places. And then there's this weird thing called inefficient conveyance of water, which is essentially what beaver dams and log jams do. They slow the water down. It's not efficiently leaving the watershed. It's having to find multiple pathways to do it. You're recharging groundwater. and we're saying that that's healthy. And this is a schematic of what that might be envisioned. So if we, instead of using that slightly confusing term of inefficiency of conveyance, if you just think of residence time, a tree falls in a river, it could get washed out in a day and out of the watershed, or it could take 100 years for it to be washed out. And so the blue line there is if you have a degraded stream, what tends to happen is things get washed out of your watershed either really quickly because the stream is simple, or it's dumped up on the floodplain, and because the floodplain isn't connected, it's stuck there for a long time. And then in a more envisioned, healthier stream, you would have this diversity of residence times. And that can be of water, of sediment, of wood, of nutrients, whatever you are interested in. And just to wrap this up, and then we'll maybe take a break. We have principles for actually implementing a restoration. So just to help you sort of not slip into that form-based approach and the approach where you want to have everything be predictable and stable. So it's okay to be messy. That just means making messy structures. You're not building houses. Strength in numbers means, these things are degraded. They've been losing wood or lost wood for over 100 years. So we need to get a lot of material back in there. And there's also strength in that the more wood you put in, the less likely wood is to be transported out of the system. We should use natural materials. We're not anchoring anything in with cables and T-posts and crazy stuff like that. And then we have a couple of sort of more nuanced and higher level type of principles. So let the system do the work. We're just trying to feed it the structure that it needs to do the restoration for us as much as possible. We're not digging channels. And then deferring the decision making. What that means is not being too hung up on what that structure might do. You may build a structure to pond, but if it fails, that's okay. Like the system decided that it wanted to blast a hole through that structure. That's actually a normal part of the evolution of beaver dams and log jams. And then self-sustaining is that's what you're trying to get to, where you don't have to add wood anymore. It's the wood is being added by the system itself, or the beavers are doing it for us. This is just an example of what I mean by strength in numbers. So we did a restoration in Southeast Washington where everything's spaced about 20 to 40 meters apart. That's 50 structures a kilometer. It's pretty dense addition of material. And I'm going to play this video. This is a group in Idaho that just gives you an idea of the number of structures, the density of structures. And Jennifer, maybe if you hop in, and if there's questions, I could start asking or answering some questions about the background. And then I'd be happy to take a 5 or 10 minute break if people would like to do so.
Yeah. There are no questions in the Q&A tab yet, so I encourage anyone who does have questions to pop them in there. But I have a question that I thought of as you were going through your presentation. One of your main messages was to know the context. And so do you have some key indicators or metrics that you're looking for I think you
Yes.
touched on like determining if in-stream structures are the driving force for processes would be one aspect of that, but are there other things that you're looking for?
Yeah, I'm going to dive into that in the planning section, which is I think the next section up. Um, it's essentially the fluviogeomorphology part of this. We've said throughout all these trainings that we've done, right? We can't train people to be fluvial geomorphologists in a afternoon or a 3-day workshop. We can give you some questions to ask, but for all the people that are getting into this that have really no background in river science, you probably should find somebody that has a background in that to help you out. It's not that complicated. And the funny thing is that we put wood almost everywhere. I mean, look at this picture. This doesn't look like, a lot of British Columbia, unless you're in Kamloops. But wherever there's water, there's vegetation. And so wood was part of these systems. Beaver were basically everywhere in North America. So even though the context of these rivers is so vast across North America, many of them did and should have beaver and did and should have lots of logs and wood in the stream. So what you're going to do won't be a whole lot different, but what you're going to expect to happen.
I think you just muted and we lost your screen there.
Oh,
Oh, there we go.
okay. Is your screen still there?
No.
Oh, well, that's scary. Okay, so I will get to that question. If there's no questions, I'm going to just ask a couple.
There is a few in the chat now, or
okay,
in the
well,
Q&A.
why don't you shoot me those, and people can answer this question while I'm answering the other one. I'm a double tasker. Yeah.
The first question is from Tyler, and he was asking about the video that you were just showing. There was a lot of what looked like vertical poles with no material in them. And he's just asking about what functions do they provide, or what's the purpose of those?
Yeah, I actually noticed that. I hadn't played that video in a long time. I think some people drive posts in and then, come back a day later or a week later and put material in. And so I think the guy or gal was just flying the drone, at the end of the day, and they had pounded the posts in on those top structures, but they hadn't finished building them. That's one possible answer. When we first started this, we actually did just drive posts in the stream as an experiment to see, do we even have to add wood? And the answer is yes. If you want things to happen quickly, you should add wood. But if there is a moderate amount of wood moving throughout your system, then it's quite possible that the posts would start to collect that wood and you would have to build less. So I don't think that's what they were doing, but it could have been.
Awesome. Thank you. There is another question from Jennifer Moss. She said we might be getting to this later, but how do you choose exactly where to put BDAs and PALs? Would you just ask a geomorphologist, or could a biologist do this?
Yeah, well, I'm a biologist and I'm not the smartest one either. So yeah, you don't have to be a fluvial geomorphologist to do any of this, but like I said, it's like if you were going to build a house and you don't know anything about carpentry, you probably would consult a carpenter. It's the same thing. That's just due diligence, right? But I've hung out with fluvial geomorphologists for quite a while now, and I feel pretty comfortable in 90% of the situations that I get into, because they're fairly predictable once you've done a few things, so as to where I'm not going to spend a lot of time talking about where to put structures because that's so hard to really talk about, over Zoom. It's much, much more interesting in the field. And I hope you'll learn that it's actually not maybe as important as you think it is. They're starved of structure. So whether you put a BDA in or a PAL or a hybrid of the two, it is actually more important, like how many you put in versus what you put in. There is certainly times when specific structures might do very specific things, but keep in mind there is a lot of uncertainty, and just because you want it to do something doesn't mean it will. And so the design part we mostly do in the field. We estimate how many structures we're going to do with desktop analysis and a field visit and some planning. But when we actually go out to build, a lot of the times we're just picking those very precise spots out in the field. And often we leave our crew saying, okay, we built this here and we built that there. Just keep repeating that. Wherever you see this situation, build a PAL. Wherever you see this situation, build a BDA. And that's the design.
Thanks. Maybe we'll do one more question and then go to a quick break. And then
Sounds good.
There are other questions that weren't answered, we can be sure to touch on them during the next question period. So Jim and Judy have asked, they said what we discovered in BC in 2018 was a significant resistance from local hatcheries and DFO to the presence of beaver dams in fish-bearing streams. There is a lack of research in Canada compared to the US using pit tagging documentation. Is anyone aware of studies in other provinces of Canada? My answer to that quickly is I'm not aware. We're hoping to do some for our projects, but nothing yet. I'm not sure if Stephen, you have some knowledge of some of those studies.
Yeah. I don't in Canada. I'm going to provide a few citations for people in the US. This is one of the more frustrating questions that I get because, there were lots of beaver and lots of fish when Europeans showed up. It's just not, we're getting distracted by something that's not a real thing. And I'll talk about that. Yeah, as much as it drives me nuts to do.
Okay. Well, thank you. Maybe we'll take a break until 2:05 and come back together for the next part of the presentation.
Okay, am I starting or are we waiting for a little bit more?
I think we can keep going. We're at 2:06 now, so yeah, I think we're good to go.
Yeah. Okay, I'll just quickly go over some of these questions we had for the background. So, yeah, I'm also going to put my headphones in. Sorry. Can you hear me? Can you just say something, Jennifer, just so I know that I can hear you? Okay, thank you. Sorry.
We can hear you.
All right. Yeah, we'll talk about incision recovery. I have a graph that maybe helps with that. I'm going to skip that question. This is interesting. So I'll maybe try to clarify the principles a little bit. I'll leave this up for a second just to see if people want to answer this. Just Okay. I would like that order is almost as the way I'd like it to be. The deferred decision making is something I actually kind of personally like. It just in the sense that it's letting go of what you want to happen, and letting the river figure that out for itself, which I think is somewhat useful, but it might also be kind of scary for people, and let the system do the work. I don't know if anybody's familiar with Let the Water Do the Work. It's a book by Bill Zedike, who does meadow restoration. We just sort of stole that title from him, and twisted it a little bit to mean beaver and water and wood. Okay. Let's go look at a graph. So there was a paper published in 2013 that really got the fluvial geomorphology world going. And this is a simplified figure from that Clure-Thorne paper. And up until this point, there was what they called channel evolution models. And it may sound trivial, but they called this a stream evolution model, which is really important because up until that point, everything we did was focused on a channel with the assumption that there was only one, a single meandering channel, which is a kind of terrifying to think of, that that's the way we thought of rivers for 100 years. But we now realize that there should be multiple channels in some rivers, and that there should be a way of a stream evolving from this size state to something other than a single channel. And so that was one big part of this paper. And we've just simplified it into these basic processes, right? So if you start at the top where you're connected, and then some rapid incision happens. So these numbers are time, T 10 to the 0, 10 to the 1 in years. Rapid incision, at some point after the incision stops, you start getting bank failure and widening. And then as vegetation grows up in that inset floodplain, see right here, this is a little inset floodplain, that allows vegetation to grow, which then starts to interact with the water and aggrade the channel and widen the channel at the same time, and you eventually get back here. But they also recognize that unlike the channel evolution model that went one way, this can go backwards. So from incision here, you could skip this phase if you're able to aggrade. And then another paper was published by Pollock, who was one of the people who started studying BDAs in Bridge Creek. And so on the left, it's looking at how beaver restore an incised stream. And so basically you have to have bank failure and widening. And that happens as the dam gets end cut. So in this section over here, and then you get your inset floodplain and vegetation, they rebuild, it widens again. And every time the stream widens, the stream power goes down because you have the same amount of water over a wider width. And that's how you go from incising to aggrading, in other words, building the channel back up. And then this panel on the left is it's the same idea. It's just that, well, if beavers can do it, we could mimic that with structures, and the same processes basically are taking place. It is also possible, though, if this doesn't fail, so either this beaver dam over here or this structure over here, if it doesn't fail, you can just degrade. And so you can skip all of these other steps. And we have evidence of places where that has happened. I've forgotten what the other questions were. Oh yeah, it was about principles. And so the space part is really important because, as I mentioned, we've encroached into the floodplain in so many places. Roads are in the floodplain, fields are in the floodplain, infrastructure is in the floodplain. That makes stream restoration really difficult. You can't restore something to its full potential if there's things in the floodplain that you don't want to get wet. And believe it or not, we get hired a lot by people that say, I like this idea. I wouldn't even mind beaver, but can they just stay in that incised channel? I don't want water out on the floodplain. And it's like, well, no, that's the whole point here. So that's why the space is really important. And the inefficient conveyance is this down here, where you used to have water just flowing through in a single channel. It moves through the watershed quickly. Here, water moves through the watershed slowly. And so you take the peak off the hydrograph, it's inefficient, is the way my partner Joe likes to describe it. I don't like that term because it's a negative term. I like it increases the residence time of water and sediment and wood and other things, but it's the same idea. Any questions or anything lingering about just that background? There's papers on most of this stuff that I can provide people with. Also, we've written about this stuff in the manual. I can only go into so much detail on it on any one topic.
Yeah, we have more questions in the chat now. One of them from Neil with BCWF has said, it appears that many staff with DFO are supporting our projects. We're finding that provincial staff are relatively risk adverse. How much modeling of downstream risk do you do, and would this be necessary or not necessary?
That is my next slide. So let's get into it. Risk. There is less risk out there, I think, than people feel, but if you feel risk, I guess it's real, but it's real, to you. Whether it's real in the actual sense is a different thing. So I certainly would encourage everybody to find places like this to do their first few low-tech projects. I'm lucky, this 15-year experiment I'm running is on a wildlife management area. This is what it looks like. There's an old road, it's gated off, the public aren't allowed to use it. And there's no infrastructure in here. There's no water diversions. There is very low risk. There's no road crossings. And for the last several decades, we've spent a lot of money doing modeling and very engineering-like activities for stream restoration. We do very little. Now, for any of you that know Joe at all or have Googled him, Joe Wheaton, he is a maniac GIS, fluvial geomorphologist, who is building lots of tools that you could call models, like the Beaver Restoration Assessment tool. He has a tool that he's run that identifies the valley bottom on all streams in the US. But we have a richer set of GIS data down here than you have in Canada, from what I can tell. We have more streams that are gauged as well. So we have a lot more data, and we can do a lot of fancy things. But I can absolutely guarantee you that you don't need any of them, because on over half of our projects, this is what we do. And I made this look as kindergarten-like as possible, because this is what I do most of the time. So you can drive out there, and within a few seconds, your eyes can see this right here. You're on the road, and then it's a steep grade down to something that's flat. This is the valley bottom. It's that easy to identify. The water is not going up here ever. You could put all the houses you want here and build all the structure you want. They're never going to get affected. So this stuff is actually pretty easy to identify. It's also easy to identify because of things like vegetation. That there's nothing growing where the water isn't, or the channel is. So this kind of identification of the valley bottom, we call it reading the riverscape in the book. The reason we're doing that is because this is the danger zone between these two yellow lines. It doesn't matter really what's going on out here. Now, if somebody has $1 million house here, they're going to be nervous, but there's a very, very small chance that anything will happen. And in here, yeah, if you have a house here, we're going to wet your basement because you shouldn't have your house in a floodplain. So don't go trying to do this stuff where people are living in the floodplain. And unfortunately, there's lots of those places. But there's also lots of places where the risk is really low. We put this in the manual too. This is a very NRCS, Natural Resource Conservation Service way of approaching things, and it's very defensible. It's just green is low risk and red is high risk, and you can go through these questions on the left hand side. What is that land use outside of the floodplain? People are, whether they're in real danger or pretend danger, are still going to call up somebody and complain. So you should be aware of that. But really what you want to know is what's going on in the valley bottom. And then as the stream order goes up, the bigger your stream, the more stream power is, the more stuff that can happen. There's no question. But that doesn't mean you can't work in fifth order streams. I work in them all the time. And then this stuff is at the bottom is about essentially whoever you're working with, whether it's the state or provincial landowner or a private landowner, what is their willingness to actually do process-based restoration? So you have to explain it to them that we're okay with erosion. Unfortunately, erosion is still a very, very negatively laden word in stream restoration. There is still people out there protecting banks from eroding. And there's, I'm sure, some good reasons for it, like if there's a road there or something. But if we are not going to let rivers erode banks, then we can't do process-based restoration. Rivers move and adjust. That's what they do, and they do it by erosion. Yeah. So you can read that at your leisure. This is Park City, Utah. Any of you that are skiers might have heard of this. This is like a international destination for skiing. Some of the most expensive property in Utah, and there's a BDA right in somebody's front yard. But there's zero risk to that house. This is what I'm getting at, right? So risk is very site specific, and there's low risk in these situations. People might still perceive risk, but the risk is low. And here's just another example. That looks like a pretty intact Beaver Madness there in between two roads, but both those roads look like they're outside of the floodplain. So that's my thing about risk. We can go back and talk more about it. It just, I'm not very good at explaining how overblown risk is, but it just is, from my perception. But what we can do to really make people more comfortable is be professional. And like I say, know something about rivers. And so when you asked about what key things are, it's this really basic stuff. There's rivers that are confined, the Grand Canyon, Fraser Canyon, those are confined. They don't adjust. They're not going anywhere in our lifetime. There's no erosion of banks there to speak of. So there's confined rivers. There's partly confined, which make up a huge array of rivers. And then there's unconfined. They're traversing across a large floodplain. So right off the bat, just figure out those three things. Are you in one of those categories? And then it's basic reach typing. We sometimes refer to it as river styles. There's a really good book written on this topic, but you're dealing with in the spectrum going from confined to over to unconfined, the high slope, high energy, coarse substrate to low slope, low energy, fine grained. And I've starred these guys in the middle because this is kind of where a lot of the low tech stuff takes place. In anabranching, the thing that we said we lost, these multi-threaded streams with islands in between them, they're just one river style. There's lots of other ones. We know less about the role of wood and beaver in some of these, but we're learning a lot more all the time. But confinement, gradient, and your substrate are some of the basic things to just figure out. And then there was a question about, where is this appropriate? Well, this was a cool paper that came out by some of the same people that wrote the stream evolution model, and they call this the stream evolution triangle. And I like it because it was, again, this recognition that for decades and decades, fluvial geomorphologists just thought about water and rocks and sediment. That that's all they thought about. Wood and beavers were an annoyance that they just swept aside. And now there's this recognition that no. So this triangle is showing in each corner what is the main driver or form of function of a river. So in this corner, it's geology, where you have high resistance to erosion. So that's these bedrock gorges. And there's not much that biology does in this corner. And then over here, you have low resistance to erosion. So things are easily erodible so much that you get into fans and really multi-threaded streams. I'm forgetting the word for that, but so low resistance but high energy. So it's high gradient and low resistance. And up here, this is the sweet spot for low tech. It's where the stream power is lower and the ability of wood and beavers to force change is high. And so those are the places we're working. So we've talked a little bit about river styles or river reach types. So you've got confined to unconfined with partly confined in the middle. The other thing that we like to describe is what we call regimes. And there's papers written on all this stuff, but in its really simplest, it's just trying to understand these four things. The role of flow, first of all, which is the hydrology, which is what people have cared about for a long time, sediment, which they've cared about for a long time, and then beaver and wood, which they've cared about for less time. And the way I try to explain this is just with the flow. So if we think of a flow regime, rivers have different types of flow regimes, and that's why we gauge streams to figure out what kind of flow regime they have. In this particular case, it's the most boring flow regime possible. So this is the year time period starting in October of one year and going to the end of September of the next year. And basically it's more or less flat. There's a little bump, so a tiny little spring freshet. This is 10 CFS. So this is a stream you can almost jump across. and it basically doubled its flow, but its flow is tiny. And so when we look at these regimes, we're thinking about magnitude, how big something is, the frequency of that high flow event, the duration, how many months did it last, the timing, when did it happen, and the rate. And then for the other regimes like wood and sediment, it's, well, where's the sediment coming from? Where's the wood coming from? What's the mode of the transport, the mode of the input? And we're just describing these. We're not measuring things. We're not going out and doing gigantic studies. We're just trying to describe things. So here's a picture. We show up here, can we do low tech here? What are our expectations? Okay, well, I can see it's got a lot of sediment coming in, which looks like sand down in the bottom right corner. So it's probably, not lacking in sediment transport. It's a relatively narrow floodplain. There's not a lot of wood. This had a 186,000 acre fire, burnt all the wood up, burned all the vegetation. It's also intermittent flow, so it doesn't even flow all year. But people are desperate to get riparian vegetation growing back here. So, this is an appropriate place for low tech, but we're not going to turn this into beaver madness anytime soon. And then we try to understand the role of the potential role of beavers. So beavers were pretty much everywhere in North America, but they weren't building dams on main stem large rivers. They were building dams in smaller streams or on the side, the floodplain of large rivers. At some point, the gradient is too steep or there's not enough food. So if your goal is to reintroduce beaver and it's all conifer, you're probably not going to be successful. So it's just describing what it is. The thing about beavers, just like everything else, there's a lot of uncertainty. We don't know how many dams beaver built in all the different types of streams. Here's a picture. This picture I'm showing you, we know a lot about. It's in our backyard. These dams have been here for as long as aerial imagery is available. Very stable population. This is out in the desert. These streams go dry, but they still have beaver in them. And I don't know where the beaver go when the streams dry up, but they're building big dams that are very influential in this landscape. But nobody's studied beaver in places like this. So as we move and work in different places, we're going to run into these challenges. Doesn't mean we can't work there. It just means we need to think about what might be happening and try to learn from our approach. So that's my real quick risk and planning. We really have a limited number of design objectives. So one that we're always excited is beaver relocation, and we don't have a lot of data on this. There's not a ton of publications, but the basic theory is that if you want to relocate beaver into a degraded stream, you're going to be less successful. So we often build BDAs so that we can build deep water habitat to give them some refuge from predators. This just happens to be a stream we've worked in for a few years. We've released 3 different release groups in here, and they've all been eaten by either bears or cougars. We have had game cams up that documented some of it. And this is a bigger BDA that we've built in hoping that the water's deeper and the predators can't get it. Other design objectives are this incision recovery that we talked about, or just making things more complex and connected. And then a big one for a lot of people is just vegetation. And I've seen a lot of people trying to plant riparian vegetation in disconnected floodplains and have really dismal success. And I'm now seeing more people realizing that you first have to get the floodplain connected before you plant, and that is a far more successful way to do things. Just little lessons we've learned that people were very nervous about us trying to erode banks. Here's a structure designed to erode a bank, and it might not be, or it might be very obvious to you now, but that's a hard bank to erode. It's boulders and cobbles. This structure's been here for 8 or 10 years. It really hasn't eroded that bank much. This is not, if this is your goal, this is not the place that you're going to be very successful doing that. However, here, this was a BDA that we built on a fairly large river in the desert. And the client that we were working with told me the next year, he said, "Oh, all your structures failed." And I went down to look at them, and this is what happened. And I was like, well, that's actually the most amazing widening I've ever seen on any project. And I've got pictures of about 20 of structures doing this. This is the widening phase that you hope for. The best case scenario is if this didn't widen and it completely aggraded. But the second best scenario is if it did this. And so this is what I mean when I say, what structure to build here? What's the most, is it a BDA or a PAL? Would a channel spanning log jam have done the same thing? It probably would have. I don't know. But if you build a BDA here and it aggrades, that is the fastest restoration you could have got. But if it fails like this, you still met an objective. So it sounds like we're trying to win in every scenario, but it's just the reality that these are both good alternatives. Here's an example of a project in Washington that I haven't visited yet, but it is one of the most amazing projects I've heard about. So on the left is they're starting to build the project. These are the same photo points. This is 4 or 5 feet in size. And after 1 year, they buried to the top of those posts. Those posts are 3 or 4 feet. And their average aggradation on this project was over 3 feet. And some places it was 5. So this is about, they probably had no idea that this amount of sediment was moving through this stream, but this is what you can do and learn by just doing a pilot. This is a stream where they've built 1,000 PALs now, and the landowner doesn't really want floodplain connection, and so they're doing this just for complexity. But you can see this is the same this is a stream that I just showed the hydrograph of. It's a very spring-fed system, doesn't have a lot of high flows, doesn't transport a lot of sediment. There's really not much going to happen here. I keep trying to encourage these implementers and landowners that there's much better things they could do. And that's to build a BDA here and flood a lot of the floodplain that is, currently disconnected. But right now they're building PALs. And in this situation, that's not a really great tool. Oh boy. So Jennifer sent me some of the different projects that she's working on with partners, and this long and short of it is that she's doing a lot of the same things we're doing, so this is just a tee up for moving on to permit stuff. But we take that planning, we describe the river, we tell people this is the kind of river you're in, this is how wide we think the floodplain is, this is where the valley bottom is. There's limited risk here. We have a little preamble, and we just have some project maps. We put some preliminary complexes together, which is just drawing a polygon around some structures and saying, hey, in this area, we're going to try and widen, and we're going to use mostly PALs. And then we might give a little table that summarizes those structures, the number of structures, the width, and give some basic design objectives. And then we provide some schematics, and that's the result of our planning phase on smaller projects. Here's just a fancy picture of that. So on the left, we've got the stream. We've identified the valley bottom, and the little tick marks here are different types of structures. We've got our design objectives or complex objectives, and some basic numbers about what we're putting in where, a photo. And these types of things get us permits. So that's the good news. And I'm going to stop talking. I have a different kind of Menti here where I'm asking for just comments or questions about what I just blabbed on about for I don't know how long, 20 minutes. Or risk or river styles, regimes. I think you just, yeah, there we go. All right. Yeah, so just going back to, so failure, what does failure mean? If a structure washes away, is that failure? And I guess the short answer is no, it isn't. Because we're building multiple structures and that will likely get stuck on another structure. If they all fail, it's telling you that that river is, got more force than you thought. But some failure is normal. And there's a woman who writes an amazing amount of papers on wood and beavers. Her name's Ellen Wool. And she just came out with a paper talking about the importance of wood moving. And this is why they call it process-based restoration. This is why I've just said all the things I've said, is that if all of your structures stay where you put them, that's probably not a good sign. You want some of them to stay, obviously, maybe even the majority in the beginning, but it's actually the failure and the movement that are one key part of sustaining this system. And she actually uses the term, the movement of wood is a disturbance event. And if you think of, for those of you that are biologists, you think about the literature that's come out in the last 20 years, right? Fires are a disturbance, floods are a disturbance, landslides are a disturbance, but they're also a natural part of the system. And, particularly with the fire, we tried to remove that disturbance from the landscape, and now we're paying a lot of the consequences of that. Well, it's the same with wood in rivers. I don't like the word failure. It's again got the wrong kind of connotation. Some wood moving is okay. Liability, I'm not a lawyer. We have insurance, and so far we haven't been sued. There's a lot of restoration to do. If we're going to get hung up on all this stuff, well, we're not going to get anything done. I don't know what to say. Whoever implements it carries the liability ultimately, and also whoever funded it, I guess. I live in a pretty litigious country, so there's not that much. I don't know anybody in the business who has been sued. I'm not going to say that it'll never happen, but okay, I'll move on from that one. If a beaver does not take over management, great question. We know for a fact that some of these structures have lasted a decade. BDAs are a little less lasting, only in the sense that they leak eventually. Beavers are maintaining their dams so that they don't leak too much 365 days a year. we build a BDA and then come back maybe next summer, So BDAs are going to leak. PALs have lasted for, like I say, a decade, at least a bunch of them. But this is kind of the conundrum, is that at some point we either have to keep building as things fail and decay, or beaver take over, or natural wood recruitment takes over. That's what we need for sustainability. Permit applications are actually pretty darn easy to write. I usually don't spend more than a day to fill out a permit. Maybe it's a couple days if you want to make some fancy maps. We usually, if we're comfortable with an area, we do a desktop design and maybe don't even visit. But the one thing that you usually need is photos of the site. So I take that back. There's usually a site visit. So the writing doesn't take very long, but the actual site visit might take as long as filling out the permit, just depending on where your project is. So writing them is easy. Getting one takes much more time. Do you have any examples of BDAs being used to store large amounts of water? Well, yeah. We've made some huge BDAs and they store a ton of water. I just showed the picture of one of them, but what is the typical time of planning? If you're talking about a project, couple of kilometers or whatever, we can wrap up the planning and all that stuff. Again, it's a site visit, a couple days in the office. It's less than a week, easily. If you're doing watershed planning, it's more like a couple of months to half a year, depending on how big the watershed is. Licensees, I think everybody and their dog is implementing BDAs and PALs these days. Yeah. I wouldn't implement I might implement BDAs in a system that didn't naturally have beavers if there was a good reason to do it. I can't really think of one off the top of my head, but the BDA as a tool is just that. It's a tool, and if that tool helps you achieve whatever objective you want, you could use it. I just can't think of an example. The majority of BDAs we are going to implement are in response to beaver threat. I'm assuming this question means that you're going to trap the beaver out and replace them with BDAs. I'm not sure what that question means, the majority, this one. So maybe somebody can clarify that one. The impacts to fish are good. Salmon learned to jump because beaver made dams. Salmon can navigate. It is not a net negative. The papers that I'll provide bring this up, that these streams are degraded. That is hurting fish. If we don't fix them, that is a greater impact to the fish than the potential for a fish to jump and land on a beaver dam and die, which happens. I've seen it. But we're managing populations. We're not managing individuals. So fish die all the time for all sorts of reasons. Fish have a tough life, but on the net side of things, the beaver stuff is way, way better than non. And it's a timing thing, which I'll talk about more. Yeah, a question about where we work. We work in mountainous areas, rangeland areas. There's a little bit less going on the West Coast, only because they tend to be steeper, higher discharge, but there's plenty of places that we're working in forested areas as well as rangy areas. Okay, somebody's asking about the benefits of extra flow. I'm going to get to that. So increased flow, let's call it. I'm going to just maybe get one more of these. What could be the risk of beaver infestation? I don't know. I use the phrase beaver infestation as a good thing. So the more beaver infestation, the better. I'll talk a little bit more about that stuff later, I think. All right. Are we due for another break, Jennifer, or where are we at here?
Yeah, we can definitely take another break, give you a bit of a breather. There are a few other questions that were in the Q&A that haven't been addressed yet. One of them is from Kurt Frey from the province, and he said that he sees two main barriers that he's encountered so far in beaver-based restoration. The first being fish passage with many interior streams now without beavers that run dry in the summer. So whenever there are beavers, the dams are removed because they are actual barriers to fish. And then the other main issue being human-wildlife conflict potential. So his question was based around the river continuum theory, and if you would just suggest focusing on headwaters first in these types of areas.
Yeah, well, without knowing the specific situation, it's hard to answer that question. But by taking those dams out, you're probably making it almost inevitable that stream will stay intermittent. And I have a very specific example where we managed to turn a stream from intermittent back into perennial with the reintroduction of beavers. So you're essentially maintaining a degraded state by removing those beaver. And I think there's other options that you could have potentially. Now, again, I don't know the specifics, but I can talk to some of that a little bit. And I think people tend to hit the panic button when they see fish below a barrier like a beaver dam, a potential barrier. I don't know when those fish are moving. Are they moving in the fall? Well, maybe they're just waiting for a rain, and 3 days or 4 days later, they can pass that structure. It's just unclear to me how much people panic versus it's an actual, real, persistent problem. And just because they can't get past that dam, let's just say that's a fact. That doesn't mean they can't spawn. They can spawn downstream of that barrier potentially. Fish have had to deal with all sorts of things all the time, and there's lots of examples of a river being cut off and the fish just drop out of one river and go in another river, or they go up a tributary. So I think we have to have a little bit more faith in their ability to navigate the world that is a complicated world they live in, and they've done a pretty good job, because if they hadn't, there wouldn't be any left. They are pretty good at figuring out how to get past these things. And in that scenario, I would suggest to people, why don't you try building more dams, not less? And so they're all sitting below a dam, right? And let's say that dam is 4 feet high and the water is a foot high. If you build a small dam below that dam and raise the water up 2.5 feet, now they can jump over that thing where maybe before they couldn't, or maybe that the water coming off that beaver dam is just, it's not going into a pool, it's just going into a shallow run. Well, if you provide a pool there, then fish can jump over. So you could enhance that beaver dam by building a BDA below it. And now you're maintaining the beaver dam that's there, which is saving that water for you, which those fish need. And once those fish spawn, guess what? Where their young need? They need slow water habitat to rear in. So that I don't know why people haven't thought of these as other options rather than just ripping them out. It's the worst case scenario of just ripping them out.
That's fair.
And sorry,
Okay,
I get a little ranty on these things. I'll apologize if I come across a little hot and heavy, but
no, not at all. Okay, maybe we'll do one more question before doing a break. I'm assuming you might be touching on maintenance later for these structures. If so, then maybe
I wasn't planning on it, that I can, well, actually, no, that's.
I can ask the maintenance question now then.
Why don't you ask it now? Yeah, I will talk about it later.
So Jennifer Todd from the province was referring back to the example where you were showing the video of moving through that complex. And she noted that there was not a lot of wood and she was assuming that there was no beavers left. So what would be the ongoing maintenance for that project? And what is the maintenance time frame? And how does this typically work for funding?
Yeah. Okay, I'll answer those in reverse order. It was not very long ago, less than 10 years ago, that I first went to my funding agency for this long-term project and said, hey, can I have some money for maintenance? And there was kind of this blank look on everybody's face. They're like, what do you mean maintenance? I thought you were done. And so it's really been in the last 10 years that not just our group, but a whole bunch of people in the salmon, particularly the salmon steelhead recovery world went, holy crap, we have to keep adding wood for decades. That's what is kind of coming out to be. Like, this is not going to get done in one treatment. And so funders are now, I think, a little bit more aware of that down here. I see people applying for that kind of stuff. And so it's become a little bit more commonplace, but it was a shock to funding agencies not that long ago. How much, when is, we don't know. I mean, every river is going to be different. We've had rivers where almost every structure blew out, so we're starting over again. And we've had other places where hardly anything's happened. Most every structure's there and it isn't really doing a whole lot, or it hasn't changed the river much, and we haven't lost a lot of wood. So we're just getting into a paradigm shift of the way we think about restoration, the way we're going to fund it. But yeah, right now it's not really set up for that. You get your little project funded. Nobody's really thinking about giving you money. So, you write a proposal that says, here's our 1 year implementation. And over the next 3 years, we'd like to have, 30% of the money for maintenance. Yeah, but you really don't know how much you're going to need to do until you go and look and see what happened. Another thing that really drives this, especially for log jams, but for beaver dams as well, is how much snow did we get in the winter? How much rain do we get? Every year is different. The return interval of large floods is long. So big floods happen less often than little floods, but big floods do a lot of work. And you have no control of when those come. And that was a big worry for our experiment, is the first 4 or 5 years, we didn't get any big floods. And so nothing much happened. And then all of a sudden things change. So I hope I answered most of those questions. it can be fairly cheap to do the maintenance, a lot cheaper if you're just adding wood or, the posts are still there, that kind of thing. But again, that's going to depend on your site location.
Yeah, thank you. And I would also like to note that just for projects that BCWF is working on, we are doing monitoring and maintenance for at least 2 years post-construction. It's been built into our funds, and ideally continuing on further after that, pending funding and future grant applications. With that, maybe we'll go into a break and come back at 3:05 for the next part of the presentation, if that sounds good to you, Stephen.
Sure, that sounds good to me.
Okay, we're at 3:05. I can see you scrolling through the chat there if you wanted to reply to any of the comments or get started on the permitting aspect of the presentation.
Yeah, can you hear me? And can you see the beaver picture?
Yes.
Still?
Yep.
Okay. Yeah, I think I'll get started because I saved the, why we're confident it works stuff till the end. So I want to make sure we have enough time for that. All right, so we'll dive into the permitting. As underwhelming as it's going to be. So I mentioned we have, a manual for this and a little pocket guide. This is in both, and it's a good reminder for me that there's certain hoops you have to jump through in life. Permitting is one of them. You have a lot that you can do as the implementer to make that process less painful and go more smoothly. And I didn't follow that advice at the beginning, and I now realize that I should have. And so I'll just walk through these bullet points. I don't like having to do that, but I want to make sure we just touch on these. So, understand the governing regulation. I know lots of people that have jobs as permitters and have worked in government agencies, right? That they're understaffed, they're underfunded, they're overworked, and they're getting mixed messages. They're in an agency that's supposed to be protecting in the environment, and they're also supposed to streamline giant developments that are clearly not good for the environment. So it's a tough business that they're in, and you're just one tiny little bit of that. And so just really try to understand, that nobody wants to do any harm to streams, and it's their job to enforce the laws and regulations that are out there. So put yourself in their shoes. But the real kicker starts with establishing a relationship. And I've seen this in real time in a variety of different ways. But in particular, we invite permitters to the actual in the field workshops, and you can see the change in them in the 2 or 3 days that they're out there. They realize that low tech is just that. It's a much different type of restoration, and it's certainly not a development activity. And the more you can interact with the permitters and gain their trust, the better. And you just have to go at the pace that they're comfortable with. But I highly recommend inviting them out to your projects. And communicating, giving them the information they need, checking in regularly, and then just be realistic about the time. if you suddenly decide you need a permit next month, that's not their problem, that's your problem. And I've been guilty of these kind of things where you kind of put it off and then all of a sudden you're like, hey, I need that thing. And it's like, well, you could have applied 6 months or a year ahead of time, So give yourself lots of time. Like I said, they're underworked and they got a lot of other permits to go through. And maybe I should have put the last bullet at the top, but if you don't do your homework, planning and design, and I do not mean modeling, I do not mean, CAD drawings and a lot of detailed engineering type of work. I just mean understand the river you're in, or at least understand what you don't know about the river you're working in, and give them the information that they need, which is how many structures you're going to build, where are you going to build them, what are you going to build them with. That, it's really a small amount of information when it comes right down to it that they need to assess whether that project is going to cause harm relative to the acts that they're trying to implement. So now it's relatively simple, but I haven't done this as much as I should have, and I can't stress it enough. I don't know whether it was a good idea to put this in or not, but since I made these slides, I'm going to go through it anyway. Years and years and years ago, I heard about this. It's I think it was published in a newspaper somewhere back east. And so this is a fella, R. DeVries, that got a cease and desist order from the Pennsylvania Department of Ecology or Water Quality, Environment and Quality. And they said, hey, there's these unauthorized ponds on your stream, like, what are you doing? They're a violation of this Stream Protection Act. And one or two of them failed and caused some flooding and debris downstream. You've got to restore these to the free-flowing stream. And it happened that those were two natural beaver dams that were built on the guy's property. He didn't build them, the beavers built them. And so he wrote back to them and basically said, the beaver weren't aware that they needed a permit for the dam activity. And he was curious to see if all beavers in the state needed a permit. And he wondered if, that they were going to provide a lawyer for the beaver. And the point he made at the end, and this is all paraphrased, you can Google this, it's a pretty funny letter. And the reason I'm saying this is because there's a lot of things underneath this that are insinuated that I think are important, right? And his last one was like, why isn't the act actually protecting the beaver? Because they are creating a good, healthy river. And so that's why I'm showing this, is because I see it over and over again. Somehow the beaver are the culprit here. And I think it's analogous to saying, the seals are the problem. They're eating all the salmon. I mean, those are the last things that should be criticized. We overfished the fish. We built all the dams. We wrecked all the rivers. It's not the seals' fault. It's the same thing here. We're pointing the finger at the wrong culprit. All right. Anyway, that's my tongue-in-cheek part. One thing that I do notice down here in the states that do a lot of restoration in general and have now taken up low tech in a big way is there's a question at the very beginning of the permit that says, is this a restoration project? That seems like a pretty sensible question to have at the beginning of your permitting process, because a lot of things that happen out there are not restoration projects, they're development. They're building hydroelectric power, coal mines, logging, whatever, they're road building. So it seems like those projects should be looked at differently. And in some states down here they are, and in others they are not. They just get treated like everything else. And then you could take it a step further. What kind of restoration it is. Are you planning on using this kind of tool? If you are, that probably should get more scrutiny. It's more likely that you can do damage with this kind of equipment. It's pretty hard to really do a whole lot of damage with a pair of loppers, maybe a chainsaw, and your own muscle power. So it's just about thinking about these things differently. I am not suggesting that permitting should be, unnecessary for this, but I don't think they should be treated the same. And I think the level of risk is certainly lower in these kind of projects. I'm not going to go into all the different acts here because I don't think it's really that relevant, other than that the split is the same in the US as it is in British Columbia. You have a federal government that has laws that it's trying to apply and permits that you have to get at the federal level. That's through the Army Corps. And then there's just a plethora of different state agencies that you also have to get a permit for. Again, some of the efficiencies that I've seen down here are that they will have a joint application. And so usually it will go to the state, and the state then notifies the First Nations or the federal government, the local government, whoever it may be, that there's one agency that you're basically talking to and providing information, and they're seeking consultation from all the different other players, and then that's how you get your permits. So it's really, from what I can tell, that it's not a whole lot different, other than maybe you do or you don't have joint applications here. I don't know. I thought I'd just give you a couple of examples. Some of you noted that, yeah, we have some arid places here. Water rights are unbelievably contentious in the United States, in the West especially. And I mean, literally, people own the water. I hope that isn't the case in British Columbia yet, but I'm not sure. And although it's extremely contentious and difficult, some of the dry places like Wyoming, Utah have actually dealt with it fairly easily. And Wyoming, you have to just apply for a water right. They were going to make us apply for a water right for every BDA. Then they realized that it was going to be a giant pain in the butt for them. And so that now you can apply for a water right for 20 BDAs at a time or something like that. It's relatively simple, it's relatively cheap, and you're really just purchasing the water right to fill the thing up when water isn't being used, like at high flow. And then in Utah, they are even more lenient in the sense that it's up to the discretion of the state engineer. And so they can decide whether you need a water right or not. And they might, and they have so far for us, not required us to have water rights on many of the places we work because they're on federal or state land, and it's not necessary. And then Idaho had a good little blow up with low tech stuff a few years ago where somebody thought that we were stealing water. They were downstream of a project. That project hadn't even started yet, but they thought that we were removing water by building. And so they shut down low tech restoration for the rest of the summer until they could figure out what to do. And now you have to reach out to the downstream and the upstream water user before you can get your permit. It's not really clear whether, if some of them complain about you doing the project, whether you will still get your permit or not. And then you have to just measure flow going in and out. And we managed to talk them into just using a staff gauge. So we're not installing any fancy gear. We just put a staff gauge in, show that the water height is the same at the bottom of the project area and the top of the project area when before we, from before we started the project to after we started the project. This is the Nevada permitting process, which unfortunately looks like it will be quite time consuming. And it could take up to a year to get a permit through there, but we've already started that process. We hadn't started working in Nevada. We did a workshop there, but we've never done full implementation. And so we're currently getting to know the Nevada permitting process and people, and it's going to go slower this time than it will hopefully the next time. From my experience, this is through the Army Corps, so this is the federal permit that we have to get. They are mostly concerned with what they call fill, and that for a long time just meant sediment. And so we got permits by providing how much fill we were going to put into the BDA, so that's buckets of dirt essentially. And then all of a sudden this year they asked for fill to include the wood we were putting in the stream. And this just brings up a thing that I have found personally, and I just talked to a friend in British Columbia who said exactly the same thing, which is it's inconsistent, the permitting process. So you may apply for a permit and they ask for the amount of fill that you're going to put in and they only want the dirt. The next time they want both. The next time they don't want either, they want something else. It just changes regionally and depending on the person that you are dealing with. And that is just both a reality and frustrating. And I don't really know how to deal with that part, but I think there's a lot of turnover in the permitting process. The people that do it, that might be part of it, and the way they interpret things in different offices. And I just threw this silly table in just to show you that it's really simple to get this data. I used to be like, why do they want to know that? I was worried they were going to tell me that I couldn't do my project if I started calculating it all, but it's just part of their regulations. They need to know how much sediment's going in a stream. I personally don't think it really means anything, but because rivers are moving, multiple levels of logarithmic scale more sediment than we're putting in, and so it has no impact on the stream whatsoever in almost every case. But they have to keep track of it. So if you want to know how I did that, you can email me, I guess. I've never been asked to do fish salvage. Fish salvage is a definite thing in many large, big river restoration projects where they're diverting the river, building new channels, all sorts of heavy machinery. We have never been asked to do any kind of fish salvage for these projects. And I don't know why we would be. Sure, maybe we step on the odd fish when we're building the structure. I'm not going to say that has never happened, but the fish generally move out of the way. And we've had numerous instances where, as we're topping off a BDA, the pond that we have just built, that used to be a shallow, narrow channel, is now this beautiful pond. It is filling up with fish, literally, as we finish that structure. Fish are that in tune to this new habitat. And we've also seen fish swimming up and over the structure, literally as we're building it. So I just don't think there's a need for this. It's expensive and probably unnecessary, but I haven't done any studies on this. Again, I think of things at the population scale, not at the individual fish scale. That's all I got to say about permitting. I'd be happy to answer or try to answer any questions on this. It's it's not as bad as you maybe think, and it's always worse the first time. I'm not going to go to Menti. If you've got a thing in the chat, I can go there, but I think it's maybe easier if you're, it just gets to be too many on the screen for me to read. We don't do any hydraulic modeling either, and I hope we never have to. I lie when I say that we've done that in one particular instance. It costs $40,000 or $50,000. It's like this a big chunk of money to answer a question that we didn't need answered, which is, where is the water going to go? It's going to go on the floodplain, and we know where the floodplain is. So it's not really giving you any pertinent information that you can't really figure out with your eyes, maybe a topographic map and a good site visit. No questions? That's
There
good, because
doesn't
then I
seem to
can.
be too many in the permitting realm in the Q&A tab.
Okay, well, that's good, because we better get going. I'm going to talk about evolution of structures and two types of evolution, and then some benefits. So we built what's called a wicker weave when we first started building BDAs. That's where you just weave willow through these posts. It's fast, it's relatively cheap, but they're pretty leaky. And we fairly quickly moved away from those to things that look more like beaver dams, build big mattresses. So that's the wood hanging off the back of a BDA, put a lot more sediment in the front end. And now we build things that look like this, that are much better at ponding water and ponding water for a longer time. And this is just the evolution of the way we built those. And this isn't the greatest picture, but this is trying to show you what this looks like on the inside. So if we go back to, I don't have it in there. It's like a lasagna. So it's vegetation and it's wide, right? So instead of the wicker weave was narrow. So water, once it finds a way through, in the front of the dam, it's going to move through the structure quickly because the structure's narrow. This thing is 4 or 5 feet wide, depending on how wide the stream is. That's what a beaver dam looks like if you ever see a dry one. And then you're putting vegetation, then dirt, vegetation, then dirt, vegetation, then dirt, and you're squishing that down. And it's just much more efficient at ponding water. And here's just a video of people doing that. And often we build it without the posts in there. It also forces you to just build a better dam. The posts are sort of a crutch. You can see the buckets in the bottom left-hand corner here. People are just as we build that pond, we're flooding out areas that we can get sediment. And so we're just going upstream and bringing more and more buckets of dirt to put on the face of that structure. And you can see now we've brought it up, 2 or 3 feet right to the top of the bank. And so water's going to start flowing around that. It's going to raise the water table, inundate the floodplain, and they're planting vegetation out there. And you can really get water out on the floodplain with these structures, and if you want to grow vegetation on a floodplain, you need to get it wet. So that's why we've moved to those structures more. They take longer to build, but they're more effective if this is what you want to do, or connect, relic side channels. Here's a one of the original pals, a couple of logs and a few sticks. It's pretty simple. Now we build things like this because we realize more is just about always better. Bigger is better. Like these things are starved of structure. Build them big, build them messy, get a ton of wood in there. And we're even pulling in trees. We use a thing called a grip hoist to pull trees in, when there's lots of deciduous trees like this available. Just a different mindset from this very conservative, just really nudging the river gently to try to beat the river as hard as you can to really promote processes of erosion, deposition, aggradation, over bank flow, those kind of things. We've even started to use this approach to treat what they call head cuts, right? So on the left is the head cut, and on the right is us basically just filling it full of wood and using some posts to hold it in there. We don't have nearly as much data to suggest how effective this is, but in theory, this should work pretty well. I mentioned Bill Zedike's book, Let the Water Do the Work. He uses rock to do head cut fixing. I have no problem with using rock when it's part of the environment you're working into, but a lot of times they're transporting dump truckloads of rock in to places where it's fine sediment, driven systems. And so that's why we are using wood, because it's degradable. It's not going to be there forever. And then you can see this picture on the left. Rocks are not a big part of this, particular area. So another evolution that we've seen. So this graph's a little complicated, but we got the bars represent three different streams, going from a little one that is kind of spring fed to a big one that has big flows, and then a one in the middle. And it's just showing what happened over time. In this case, about 7 years. So we built 200 structures and then tracked them through time. And on the left, we've got the ones that percentage of them that are completely gone in the three different streams. And then on the far right, we've got the ones that got, are completely intact. They got larger, or we even have new ones. And so this new ones is where wood moved. And the red line is sort of showing that, it's not quite equal, but we're sort of replacing the ones that moved with these new structures. And then we have all these other types of evolutions in between, of partly intact, mostly intact, etc. So it's dynamic. That's actually a good thing. We've lost lots of structures. You have to get over that. Lots of structures get buried. You really learn a lot about your sediment dynamics. The arrow's pointing to a structure there. It's buried in 2.5 feet of cobble in 1 year. Who knew that kind of stuff's moving down this river? Well, we know now. And then, the picture of a structure was a pretty piddly little structure when we built it. We did some maintenance. We had big floods, and now it looks like this. And then I just threw in some pictures of a natural beaver dam that has breached on the far river right here and is drained. That was in 2017. They patched it up, and for up until last year, this is what it looked like. And so fully intact. You can see water going around the right side again, river right. And then, sorry, that was last fall. And then this is this spring. So it blew out again, dynamic, failing, being rebuilt. That's what beavers do. It's a total natural part of the system. That's what we need to do until we get sustainability in these systems again. I'm going to keep going because I see we're out of time pretty quick here, and I want to talk about all the science. So attitudes towards beaver, still bad. I asked you some questions earlier, and I think I got a hint that A lot of you agree with me. Nobody likes beaver chewing down the trees in their backyard. They're treated as a nuisance, really. Still, it's a problem, and it's got to change. It is changing. I see old ranchers and stuff that are starting to be more beaver friendly, but it's changing slowly. We try to do a lot of what's called living with beaver. There's just simple techniques to do that, but right now there's really no funding anywhere that I know of to do this. And I'm guessing there's little funding in BC to do that. So the best thing you could do is keep beaver where they are, because relocating them, there is a high mortality rate. It's just pretty much the case for any relocation of animals. Beaver, no exception. This is a well-known study in Nevada where all they did was change the grazing practice. They just left the cattle out, in the 80s and the 90s all summer, and this is what the riparian looked like. Then they switched to a intensive fall grazing. Slowly the willow came back, then the beaver came back. The thing I love about this story is that the guy reported increase in cattle production from just changing the way he managed cattle in the riparian area. And we got beaver back on the landscape. This is a paper that we're trying to publish right now. This guy on the left, Jay Wild, amazing rancher in southern Idaho, about a half an hour from my house. He tried to relocate beaver to his property and his grazing allotment because there were beaver there when he was a kid, and he went away, worked as a mechanic for a while, came back to be a rancher again 30 years later, and no more beaver. They didn't stick when he tried to relocate them, so he contacted Joe, and we went out and we built some BDAs to release the beaver, a new set of beaver in there. The other thing to know about the stream is it went dry every year, and Jay documented the day it went dry every year, pre-beaver and then after beaver were reintroduced. So we built some BDAs. The red arrow is where we built a BDA. This is just us being humble, and the beaver said, well, I don't think that's a good location, and they built their dam downstream of our BDA and built a much better structure. But what happened was we released beaver over a couple of years. We built 25 BDAs. Within a year of them, the beaver establishing, there was 50 dams. We're now 6 years into it, and there's over 200 dams spread out over about 3 miles. So that was amazing just in and of itself. But as I mentioned, Jay recorded when the stream went dry every day, or every year, sorry. So these blue dots are before beaver. And so we took that date that the river went dry. And so this y-axis is what is the day that the river went dry. And we built a model, just a simple regression model. And we used the cumulative flow of a nearby stream based on the snowpack and like snow water equivalent. And so you can see we have a 96% chance of predicting when the stream will go dry before the beaver show up. Then the beaver take off, and the numbers here are the year that the data was collected. So these dots are the same dot as when did the stream go dry. And what you can see now is that the stream went dry later in the year after beaver. So we turned this thing from intermittent to less intermittent, and in 2023, it actually ran year round. The only reason we could do this little ad hoc study is because the stream went dry. If we were trying to, measure, did the flow change, it is so much harder to do that. But because you have a yes or a no, this was actually the ideal situation to study this. On top of that, we had historic data on cutthroat trout density. And so that's 2001 and 2012. And then we compared that to what was the density of fish and in the unimpounded areas, and which is the dark color. So the free-flowing parts of the river that still didn't have beaver influence versus the places there was beaver. And it was about a 500% increase. So it's not a full-blown study, but it is an amazing study. We'll look at a beaver being relocated just because we're talking about beaver all day. And the anecdote here is that the person that just released that beaver is a 84-year-old third-generation beaver trapper who now has made it his mission to never kill another beaver, but just relocate them. And so that's where, I have some hope that, attitudes are changing. This is the bad part of that story. So Washington is a pretty progressive place. They have a beaver relocation program. That's exciting. It has no funding. That's not exciting. But here's some of their own data. So in the last 8 years, on average, we've relocated 40 beaver in Washington, the state of Washington. But we've removed them from the ecosystem, either lethally or by harvest for fur, at a much, much higher rate. So it's great that we're doing this, but I don't think we're gaining traction at the moment. So again, we got a long ways to go. I'm going to save beaver questions to the end. I'm going to answer the question is there, there's lots of places not to do this. We took on this challenge. This is Pataha Creek in Southeast Washington. It's about 20 to 30 feet in size. It didn't scare us though, because we've been doing this for a while. We're like, hey, we can deal with that. This is also 100% reed canary grass in the bottom, which is non-native and very good at occupying floodplains. There were some beaver downstream, and where the beaver were, there was less reed canary grass and more willow. And so that was our goal, was just to get some woody vegetation growing here. We built some structures, we trapped some sediment, we were excited, but the grass would just grow over everything. We tried to plant willow. The beaver that were mulling around in the stream ate all of it. And then anything that did survive got taken over by the reed canary grass. So invasives is a problem. We've semi-given up on this project. I might go back there one day, but we have to do something different. Here's an example of, on the left, this is an aerial image, just a dry stream bed, and each one of these little brown things is a structure, and they're all pals, and this is a photo on the ground. We are being asked to work in a lot of these places. They may have been perennial at one time. Now they're dry, they're cobble fields. This is going to take a long time to change into anything exciting. I'm not saying we shouldn't work here, but I'm saying if you want to show your funder wonderful results, this is probably not the first place you want to start. It is a really tough place, and we're not sure whether this was always intermittent. A lot of the anecdotal information from old timers is that no, it did used to flow, but it isn't flowing now, and it may be a long time before it does. Keeping going. How are we doing? Oh boy. Okay. This is where it all started, Bridge Creek. It was an incised stream. The BLM changed the grazing practice, and that green line that you see in the middle, that's willow growing back. So there was no willow there with heavy grazing. Then willow came back when the grazing stopped. Beaver moved in, but all their dams failed within a year, or 90% of them. And so the beaver couldn't get any traction. And so that's where the BDA idea came from. They first started driving posts into some of the beaver dams that were there to shore them up and help them last longer. Then they thought, heck, why don't we just try building our own dams? So they built 120 over 4 kilometers. This story gets misinterpreted. So what happened is after they built the 120 structures, beaver managed to get a foothold, and then they went to town and really built up their own dams. And so there's now over 300 beaver dams there. This gets often recited as, BDAs did a good job here, but the real story is that beaver took over. One of the things that people worry about is, temperature. We did a temperature study. So this is a complicated graph, but we're the different groups of boxes there from top to bottom. We're going from upstream to downstream, and then from left to right, we're going from before restoration to after. And so on the left side, the red line is where beaver are, or the beaver dams were built, but this is before restoration. But this is what the temperature was where those BDAs were built. And what you can see is that it was generally warmer where we were going to build BDAs and where there was free-flowing water and the controls. And then when we hop over to this right side, you see all the red is knocked down. It's dampened down. And that's evidence that that's what the beaver did. They dampened down the high temperature. It didn't actually change the mean temperature, but it dampened down the highs. So that's at like this broad scale. And then we did another study looking at this heterogeneity of temperature within a much smaller area. So on the left, you've got a beaver dam, and we put a whole bunch of temperature probes there. And then on the right, you have a free-flowing section. And each one of the black lines is a temperature probe. And so the takeaway here, you have this high variability in temperature within not just a few hundred yards where the beaver are and where there's free-flowing water, the temperature is all the same. And so that's because you're getting hydraulic head from the beaver dam forcing water into the groundwater, and then that water's coming up somewhere. And so it's either not warming up as fast or it's actually getting cooled. Fish passage, we've talked about that a bunch. So we have pit tags everywhere, and pit tag antennas. This is before beaver showed up, but there was still 22 beaver dams, natural beaver dams, and we're looking at adult passage from the top of the bottom to the top of this, and this is 20 or 30 kilometers long. And so 17% of the adults that came into this stream went all the way up to the top before restoration. After restoration, in this case, in 2016, there was 164 beaver dams and BDAs, and 29% of the fish that came in moved all the way up. We also had pit tag arrays looking at young fish, and they were going up and down daily between beaver dam areas and free-flowing areas. I'm not saying beaver dams can't be fish passages for some period of time in some situations, but on the whole, they are by far a net benefit. And you have to think about the temporal thing and the effect on the population. Here's just a classic example of all the different pathways that fish have to get around these things. And if you're not sure, you could build another structure to downstream to help them. Here's some studies. I'll give this whole PowerPoint to Jennifer. So this is what put low-tech on the map, is the fish increases. So 160, 70% increase in abundance. Growth decreased, survival went up. That's a density dependent thing if you're a fish person. But if you times all those things together, you get production, and they showed a 170% increase in production. We're still monitoring this project, not as intensively, but the beavers are still there. They're still maintaining dams. It's maybe getting close to sustainability. This was a major drought period in the last couple of years. There's actually less fish there, but that's from the drought. The beaver are doing their part as far as we can tell. The other experiment is on PALs. We have this simple stream. We had 650 PALs over 9 miles. That's 14 kilometers. this is where the time and the maintenance part comes in. So the red line is pre-treatment, and then we have all these the short-term responses. So here's our maintenance. We're looking at the amount of wood in the stream. Our first treatment bumped the treatment density of wood higher, but not by a lot. And as we got more confident, we just kept adding wood. And then we had a fire, which added more wood. We saw the same response to the habitat. So a little bump in pools after, but not very exciting. As we were doing this maintenance of adding more wood, the pool stuff went up. We have other ways of measuring habitat response, but I'm not going to go into those. It got more complex after the PALs were put in, but PALs aren't as good at getting water out onto the floodplain. So we started putting more wood in, and after the fire, we had all these big trees. So then we just started dropping trees in. We're getting, more aggressive. We also started building BDAs strategically. So not very many, but in strategic places. So in this case, there was a relic side channel just sitting there, but we couldn't get water on it with a PAL or out onto it. So we built a BDA, and boom, we got this big side channel, 300 meters long, connected. And then we built a bunch of structures in there, and now it's full of fish along with the main stem. What we saw in the Uncertainties, in this other place where we did PALs, much smaller response in fish. And the reason why is they're two different streams. Bridge Creek is unconfined or has a much wider floodplain, is lower gradient, so has lower stream power. The Uncertainties, higher gradient, narrower. It's partly confined, but it's on the low end of partly confined. So there's not a lot of floodplain. It has more stream power. So this is a good example of how you can get different responses, doing the similar kinds of things. I'm not even going to bother explaining that right now. That's basically the end. I want to leave the rest of the time for questions. I can summarize this stuff later. So I threw a lot at you in a short period of time there. So.
There is a question in the chat that's gotten quite a bit of attention. There's a bit of a lead up to it. So some people have encountered the following perspective, that prior to unfettered capitalism, beaver populations were impacted or managed by First Nations, including trapping and removal of dams, etc. And in some previously glaciated areas, beavers and people colonized at the same time, i.e. there were no pre-human beaver populations. As such, there may be cases where beaver proliferation could cause problems for fish populations if local First Nations do not have the ability to freely trap beaver and remove dams. And so Oliver thinks this is a very useful perspective to consider, whether you agree with it or not. And so when we do let the system do the work, do we consider the Indigenous peoples as part of that system?
Yeah, I know there are some very, very few studies, but there are some, let's call them paleological studies of beaver. And one in particular where they actually could use ground penetrating LiDAR or radar, they could see old dams, buried under feet and feet of sediment. I mean, I'm not going to argue. I don't know the answer to that question. If some tribal members or band members, have local knowledge of those kind of things, I can't dispute that. I know. I think what we do know though is that when Europeans showed up, there is well documented cases of them complaining about the swampy valleys that they had to traverse to get from the East Coast to the West Coast. That is well documented. And so there may have been, well, not there may have been, I'm sure that natives use beavers for all sorts of things. And, but I doubt very much that there was, that there wasn't way more beaver when Europeans showed up compared to now. So I'm not disputing that natives didn't have an impact on beaver, but I'm saying there was a ton more beaver before we showed up. I think that is pretty well defensible because we have the trapping records.
Yeah, I think that also plays into a question that Jennifer Moss had in the chat, which was, how often, if ever, do you pay attention to information about beaver population abundance in areas where you're planning restoration projects?
Oh, quite a lot. Yeah. So that if the planning, right? Try to understand your river. So is it a little river, a big river? Does it have a stable flow regime? Understand beaver dynamics was part of that, right? So if there's beaver there already, you have to think carefully about whether you should even be doing any work there, right? And when we do beaver relocation, especially, that is part of our permit, is if there's beaver there already, you're not allowed to take them there, without special consultation. Like maybe, there's some reason to do it for genetic purposes to get increase the genetics of that population, but no, you want to understand where beaver are. One of my first questions is always, where is the closest source of beaver? If we're going to do restoration here, is it likely that a beaver will show up in next year or 100 years from now? Like they're so far away that it's not in my lifetime that beaver will ever get there on their own. But that's definitely a part of our assessment.
And looking at time here, we have 4 minutes left.
Damn.
We've covered a lot though, so appreciate all the time that you've and all the topics that you were able to cover in this time. Just looking at the Q&A chat, there is a question from Ryan Lapointe about what considerations or options are available in highly degraded landscapes that might be highly developed. Examples so far have mostly been very rural.
Yeah, well, I showed the one picture of Park City. I think highly developed doesn't necessarily mean high risk. So it's just about assessing the risk. There's certainly places where it's going to be very challenging. I forward you somebody who is associated with our company just did a PhD on developing a beaver management plan for the city or region of Denver. As a major metropolitan area where they're actively working to maintain and allow beaver to be part of downtown parks in Denver. So the answer is it can be done. It requires a different level of thinking and some serious planning and outreach and things like that. But it can be done.
Thanks. Yeah, if you send that to me, I can pass it along to everyone as well when we send out the slides and the link to the recording. I guess maybe we'll have time for one more question. We have another question just relating to maintenance and how maintenance is addressed with the permits that you have in the US. So are your permits active for a very long time that allows you to do continual maintenance as needed, or do you need to keep reapplying for it?
It's a bit of a mixed bag. Depending on when you apply, it's you could get a permit for up to 5 years from the federal government, and that's because the way they basically get recertified. The Army Corps gets certified for you to be allowed to use their permit every 5 years. So if you apply on year one of their permit to put the sediment in a stream, then you have 5 years. They also don't care if you do maintenance, because to them that they've already permitted you to do the project. So as long as you're not extending the extent of the project, you don't even have to ask for permission. You can, again, it never hurts to say, hey, I'd like to do some maintenance. This structure broke out, but that's what they've told us. So it can be that easy. Other permits only last a year, and it's just all over the board. You may have to ask to go back. So whenever you can get longer permits, it's always, a great thing to do, but it's usually 1 to 3 years with one exception of a 5-year permit.
Nice. Well, thank you. And that pretty much puts us right to 4 o'clock. As people are trickling out, everyone's been saying thank you so much for an amazing presentation. And I would just echo that. This has been really informative and great to visually see and hear from your experiences. As I mentioned, I'll be sending a follow-up email sometime next week that has Stephen's slides as well as a link to the recording of this presentation and some of the resources that Stephen mentioned in this webinar. I think feel free to reach out to me at